All right. Welcome everybody to COMP211. This semester we will be teaching remotely due to the need for social distancing, but I'm so excited to have you join me for our first attempt at live streaming a lecture on YouTube today. As we get into the semester, there will be a number of other ways that we will connect with one another through Zoom and some other means, but we will be using YouTube as we move into the semester. And today I'll have my TAs join me in a number of different moments and to give you a sense of who it is that you'll be working with this semester. But first, let's talk just a little bit about COMP211 and what to expect. So this is Systems Fundamentals at UNC. And this course is really about three big themes. The first is, of course, systems programming, and that's what the name is all about. So systems programming, I'll get into some more of the details in just a little bit, but what we're doing is we're getting closer and closer to the machine, and we'll be working with a programming language that's a little bit lower level than you're used to using in Java or in TypeScript or Python. So we'll be spending a lot of time with the C programming language this semester and doing some systems level programming. We'll also spend a lot of time thinking about representations and how to translate between them. And I'll talk a little bit more on this, but you're already kind of familiar with the idea that we've got variables that can hold different types. Integers in Java can hold varying sizes of data. And this will be true in C as well. And we'll be thinking a lot about how is it that our data is actually represented? How does the computer know the difference between a character in a string, a letter, or a number such as an integer, and a number such as a floating point value? And then we'll be spending some time getting comfortable with some tools that are really valuable for computer scientists to know. And I'll come back and talk about these tools in just a little bit. First, I want to give you a little bit of a better sense of where things fit in the new curriculum, because you're a member of the UNC cohort who's going through this new curriculum. You're somewhere in the process of navigating this. So I just want to give you a reminder of where things are and kind of set the stage for how to think about this course conceptually and where it fits in. So I'm going to really quick say that most of you probably started with me in 110. And 110 is all about introductory programming. It's seeing programming concepts for the very first time. And we're just really trying to get comfortable with thinking computationally in 110. Typically, the standard path moving forward is going to be from 110, folks go to 210. And 210 is data structures, right? So many of you just completed the pilot of data structures in the spring. And you got a sense of how is it that we can make something like a hash table or think about binary trees and think about the runtime complexity or the memory complexity of our data structures. And what we're doing is we're getting a sense of how we can start to build larger and larger programs by cleverly structuring our data. From 210, we call this sort of the applications path because we're moving closer to trying to build real applications for end users. And many of you will also be in the new version of COMP211, which is COMP301. And this is, you can think of this as foundations of programming or software architecture is another way of thinking about this. And this is really about how do we write large scale applications that we can use to build graphical user interfaces or mobile phone applications. And how do we think about some of the patterns that we design our programs with to write larger pieces of software that are interactive and sort of behave in the ways that we've come to expect. Similarly, people tend to take, and it's in the future required with 210, 283, which is discrete structures. And this is, as many of you know, a theoretical math course where you're learning a little bit about sets and relations and Boolean logic and some of these types of concepts, and starting to learn how we prove things in computer science. And this tends to be followed by 455, which is the theory of languages and automata, and how is it that we can prove things about the ability to compute certain problems. And how do we think about grammars and computer languages, some concepts like this. So this is our theory track. And this is our applications. I'm going to call it the applications track. And then finally, that brings us to where we are in this course, which is 211. And this is systems fundamentals, where we're starting to get closer to the machine. We're going to see that some of the things that we could assume in Java or in JavaScript or TypeScript, some of those assumptions don't hold true anymore as we move closer to the machine and try and get our hands a little bit dirtier with how is it that a computer actually works? And what are some of the concerns that we might have if we're working directly with memory in our programs rather than some of the abstractions that higher level programming languages provide to us? And 211 is followed typically by 311. And this is where you actually get into the nuts and bolts of what really is a computer. How do the components of a computer, how are they organized such that computation can be even made possible? You learn about assembly language and really all of the mysteries that we've kind of taken for granted are unveiled in that course. So that would be the course to take after this one. And so this is effectively our new introductory sequence, and hopefully that answers and gives you a better sense of where we fit in. We're moving closer to the machine in this course and practicing and learning some new tools along the way. So just to quickly, for those of you who haven't taken a course with me, I want to introduce myself, and then I want to introduce some of the team because we've got them on a Zoom, and I'll get them in here in just a second. All right. So I've been teaching at UNC since 2015. I graduated from here in 2007 with my undergraduate, a BS in computer science, and took many of the same courses that you all are in the process of taking. I went to Brown University in Providence, Rhode Island after that and did my master's there. I went to industry after completing my graduate work. And then in 2015, I came back because I had always wanted to try teaching, and here we are. So really the motivation for this course was it felt like it was the missing course for me when I was an undergraduate at UNC. I went to Brown University and found that they taught some concepts there to their undergraduates that were very unfamiliar to me, that I wish I had learned, that made them very productive and helped them when it came to getting internships and being more comfortable operating a computer and understanding some of the nuts and bolts. And so ever since then, I felt like this was really the course that our undergraduate curriculum is needed. And I'm really excited that this is the first official offering of it, where it has an official course number. We taught it in the spring for the first time as a 390, but now it's officially 211. And it's pretty cool to have seen a course go from an idea that I had coming into this new job to now you all are the first cohort that we're teaching the real first offering to. All right. And so I'm really excited for that. And now what I want to do is pull in some of the TAs to introduce themselves. So real quickly, I'm just going to put up some names here, and one moment while I switch over to Zoom. And I'm going to start with Alana. And I'm going to really quickly switch over to a view that should allow you to see, or Larry, go ahead. We'll start with Larry.
Sounds good. Hi everyone, my name is Larry and I'm a rising senior majoring in computer science and economics. And I'm actually from Xi'an, China, so I'm an international student. So I'm very happy to be the TA for this course and happy to work with all of you for this semester.
Great, thanks Larry. And Alana, if you'll give a similar introduction and maybe tell some folks what you were up to this summer.
Yes. Okay. So hi guys, my name's Alana. I'm also a senior. I'm also majoring in computer science. I'm from Durham, North Carolina, so I've lived around here my whole life. I'm also super excited to be TAing for this class. And this summer, as in right now, at this very moment, I am interning for Amazon as a software development engineer. I'm still finishing up that this week, so that's rough, but yeah, I'm excited to meet you guys during the upcoming semester.
All right, I'll go to Chris if you want to jump in.
Yeah. Hi everyone. So my name is Chris DiSerafino. I am a rising senior as well, originally from Raleigh, North Carolina. I am majoring in computer science and political science. I'm really excited to work with everyone. And I was able to work with the pilot last semester, so I'm sure we'll have another great offering of 211. And I guess I'll add in this summer I was interning at Bank of America. So yeah.
Awesome. Yeah, so Chris and Alana worked with the course as well as Larry last spring, and I'll go to Cindy next.
Hi everyone, I'm Cindy. I'm a sophomore majoring in computer science and Italian. I can't wait to meet you all. I'm from Chapel Hill. I've lived here my entire life.
Great, thanks. And Cindy is one of the members who took the course in our pilot offering, and I'm excited to have Cindy back. Dylan, if you'll introduce yourself.
Hey everyone, I'm Dylan. I took this class last semester and I really enjoyed it. I'm from just north of Charlotte and I'm a computer science major, sophomore. And I just can't wait to help everyone out.
Great, thanks. Eric, if you'll introduce yourself.
Hi, I'm Eric. I'm a sophomore. I also took this class last semester and it's pretty challenging, but I thought very enjoyable. So I'm very glad to help out. And this summer I took 2 math classes online. And isn't that great?
Great, thanks. And last but not least, Milan Patel.
Hi, I'm Milan Patel. I'm a rising sophomore. I'm studying computer science and statistics. I, along with Eric and the rest, took this class last semester. And during the summer, I interned at SAS, where I used a lot of the tools that you'll learn throughout the semester. So I can definitely attest to how rewarding this class will be for you all.
Great. Thank you all for joining for this. There are a few TAs who weren't able to make it, including Maddie Huber, Matthew Kirby, San Bei, Hannah Tischer, and Jules Perkins, and you'll get a chance to meet them. Either I'll introduce them as soon as they can make one of our meetings or over the course of working with them in office hours. So TAs, I'm going to go ahead and close out the Zoom, and then I'm going to continue on from here. All right. So there are a few other people that we're going to meet in this amazing journey through learning a little bit more about Unix and some of the little languages that we experience in systems programming. 2 that I would just want to put on your radar right out of the gate. Lorinda Cherry. We don't yet have a reason for why I'm calling her the pipeline queen, but there's this awesome video from Bell Labs in the 80s that I'm really excited to get to because it's one of my favorite technical videos of all time. She's a complete badass, and it's just a great moment in computing history. And then Ken Thompson is another. Ken, you will see, invented some of the fundamental ideas that we'll be interacting with in this course. And so here's 2 other members of our extended team, as I like to think of them. Right. So one of the things I want to say, and I'm seeing a few questions come in live chat, and live chat, I'm not sure how easily I'm going to be able to sync up to them. But what I want to say is for questions, I've set up a poll everywhere. And what I'd love to do is actually have folks join the poll everywhere. And the information for doing that is shown here. And there's an open way for asking questions, and I built in a few slides here that will allow me to step back for a second and take questions while you all are asking them. Right? So I'm actually going to disable live chat for now, and we'll focus on asking questions in this way if there are particular questions as we're moving through. And I'm going to go ahead and continue on with some of the material, and then at the next question point, I'll check and see what's come in. All right. So I want to dig into some of the concepts that were mentioned a little bit earlier, right? And the first is systems programming, right? And so systems programming really has to do with programming language concepts that involve things like data representation, machine instructions, and how your programming language is actually translated into machine code. Pointers, how we can reference different parts of memory. We'll spend a lot of time looking at pointers and getting comfortable with this concept. Runtime environments, which are how is it that your program actually is organized in the machine as it's running. And in 110, we actually introduced some of this with the heap versus the stack. And that was really in an effort to start to get comfortable with these ideas of there being special areas of memory. We'll dig much more into that in this course. Additionally, there are different execution models that we can expect, such as how is a program run when it's if we compile it and then run it as a binary program versus as a scripting language. And if some of these words have no meaning to you yet, that's totally fine and somewhat expected. But I want to start setting the stage for what you can expect going into this semester. We'll also spend some time thinking about what is a process in a system that has many processes running. We haven't really in any of the courses up till now spent a lot of time thinking formally about what a process is, but we'll see that the process model really helps us think about our running program, and the operating system is going to be responsible for organizing our processes such that they can run simultaneously, or what feels to be simultaneously, without bothering one another. We'll look at memory management, and this will be a new level of concern that you've never had to think about if you haven't written any C or C++ code before, which I expect most of you have not, if not all of you. We'll look at systems and API calls, and this is the idea that we can have our program actually ask the operating system for some resource, or for some file, or for some extra memory, or for something out on the network. There are a number of reasons why a process might ask the operating system for some resources, and that's done through what are called system or API calls. We'll also look at input-output for file I/O, and we might get to some network I/O as well to sort of set the stage for the networking course that comes later. All right. We'll be exploring representation transformation and spending some time getting comfortable with how is it that out of zeros and ones, we're able to work in a modern computing environment, right? So data and code are translated from what we write as humans into something that's interpretable and computable by the machine, our computers, right? And so we'll look at a number of different ways in which or strategies that programmers and computer scientists over the years have developed for processing this kind of information. So regular expressions are a little language that we'll use to describe textual patterns in a way that we can actually compute them in a very efficient manner. We'll look at lexical analysis. This is the idea of how do you take some text or a big string of input and understand its structure. We'll look at how do we parse and how do we derive meaning from some structure of text. And we'll spend a little bit of time looking at code generation versus evaluation. And this is the idea that we might generate some machine level code or actually just interpret it on the fly. And we'll spend more time looking at the difference between those. And that actually goes right into the next subject, which is the difference between when you compile a program, which we'll see we do a lot of when we're working in C, and you kind of do this in a way when you're working in Java, but I bet that some of this would come as a surprise to you, even though we've spent some time working in Java in a previous course. Versus an interpreter, and you've actually worked with interpreters before, where in TypeScript or JavaScript or Python, these are interpreted languages. We'll look at the differences between those things and some of the fundamental trade-offs. And well, in the last one here, bytecode virtual machine, this is actually when you've been using Java, it's based on a bytecode virtual machine, and that's all some fancy terminology we'll come back to. We'll spend some time looking at some of the fundamental tools for writing machine code that will pay dividends when you get to 311, such as the assembler and what a linker and a loader are. I think one of the most important aspects of this course, and you heard Millen mention this, is that we're going to be spending quite a bit of time looking at tools for computer scientists. And these tools are things like command line interface shells, text editors, compilers, and these things are, you're going to think to yourself, I already know how to use a text editor. I've been using Eclipse. I've been using VS Code. Well, we're going to spend some time with a really fantastic text editor called Vim that has a learning curve, but once you're comfortable with it, you can be way more productive than you would have imagined otherwise. We'll be spending some time looking at test harnesses and unit testing. This is, again, something that we've seen in prior courses, but we're going to spend more time thinking about them from the software engineering standpoint and what you need to know in order to be effective in industry. Debuggers, again, another subject that we've kind of experienced in passing, but they'll be very valuable to be able to understand what's going on in the memory of your program as it's running. All right. Additionally, we'll be spending some time with version control software. And I think one of the things that you're going to see with version control software is that you've been using Git to submit assignments in 210, but you probably haven't known exactly what was going on when you made a commit or things like that. All right. And lastly, workflow automation. This is shell scripting, and this is really cool. It's a really powerful way to be able to automate a sequence of steps between many different programs, right? Most of the programming that you've done up until now is like you've written all of the code for a single program. And with workflow automation, we will be looking at how to combine these steps into one larger one. So I'm seeing real quick, I can drop in, we are taking questions on Poll Everywhere, and it's pollev.com/compunc. You do need to be logged in order to work with that. All right. Great. So another thing that we're going to spend some time with is how to think about the software engineering development process. And what I've heard from many of the people who took this course in the spring or who took pilots of some smaller pieces of this is that having access to understanding these tools before you go into an internship has really helped make it much more effective of a ramp-up process at a new internship, right? And so things that we'll see and get practice with are things like program style. We'll be looking at code style. We'll be doing test-driven development, pair programming towards the end of the semester, and how we work in version-controlled projects and getting really comfortable with Git. Git is a version control software utility that is extremely powerful, but also kind of confusing if you don't really know what's going on, right? So I think these are some of the key benefits to being in the course. And just to further dig into why this is important to your career is because if you go off and you become a scientist who's working in a lab and processing data and doing data science, or you're a software engineer, you're going to find that you depend on these kinds of tools for your day-to-day work, right? And being able to wield these tools is going to make you much more productive. It's going to allow you to focus on the real problem that you're trying to solve, as opposed to spending a lot of time just mucking around trying to get your tools to work, or doing a lot of manual repetitious labor to get some program to run over and over again, right? When you know what tools are out there, you can avoid reinventing the wheel, and knowing kind of how to decide, should I write this program myself, or should I use one of the common off-the-shelf utilities that can do something very similar? And so my goals really for you in this course are laid out here. And I'll upload this slide deck to Sakai just after we get off this lecture. So we'll spend a lot of time thinking about abstractions, and this has to do with data representation. It also has to do with just software engineering and systems building in general. And thinking about layered systems is one of the ways that we've been able to develop stable, reliable software that grows in its capabilities without becoming a huge mess of a piece of software. And so by thinking about abstraction layers and APIs, we can write system software that is reliable and well written. We will look at learning how to learn new languages and tools on your own. So unlike in previous courses where you may have been taught the programming language directly, we're not going to be doing that in this course. We're going to be relying on external tools and resources to help teach you the C programming language. There will be some aspects we teach and focus on in lecture, but by and large, the syntax is pretty familiar if you're coming from Java. So we'll expect you to learn the nuances of this through reading in the book about it and practicing on your own. And this is really how you learn a new language out in the real world. And so we're starting to get some practice with that. And really, I think one of the things that's challenging as you're getting started in computer science is you don't know how to think about starting a new project on your own outside of sort of the way the course that you've previously taken set you up for it, right? And so in this class, I'm really hopeful that you'll have a better sense of how to arrange your tools and start a new project, as well as when you are trying to explore some new technology and they start saying things like you're going to need to use Make or Docker or a shell script, that you'll have a sense of what it's talking about and know how to navigate that. And I think this is really valuable for trying to start projects on your own and pursuing the ideas that you have for software, right? we're going to see that little languages are a central theme. So not only are you going to learn a full-on programming language in C, but we're going to see a lot of smaller languages that aren't really, you wouldn't think of them as true programming languages, but the name little languages aptly describes what they are. In fact, this was a term that was coined by a UNC PhD alumni who graduated in '76, John Bentley, and he's got a really great quote in the paper that he wrote that invented this terminology. So languages surround programmers, yet many programmers don't exploit their linguistic insights. And we actually haven't spent a great deal of time in 210 or in 110 talking about the grammars of our programming language or how to think about them from a language perspective or a linguistic perspective. Well, in this course, we'll be doing quite a bit of that, and we'll look at how grammars are expressed. And then in COMP211, you'll learn a lot more about how you can prove certain properties of grammars and things like that. But we'll use linguistic insights to derive some ideas for how we can exploit little languages to do fantastic things that we couldn't otherwise. Examining programs under linguistic light can give you a better understanding of the tools you now use. So you're going to see that there are things built into your text editor, like regular expressions, that you probably haven't known how to write a regular expression up until now. And these little languages give you the ability to specify what would otherwise take quite a bit of code if you were to try and write it in Java or C or something else. These little languages are concise and little tools that are built into many of the things you already use that will allow you to do some very powerful things with very little heavy lifting, and can teach you design principles for building elegant interfaces to your future programs. And this is a place where, when we get towards the latter half of the semester and we start looking at how would you actually build a command line interface, how would you build a shell, you'll see that if we exploit some of these ideas from languages, we can write very extensible, very expressive pieces of software, and it's pretty great. So just to give you a sense of some of the languages we'll encounter, we'll see things like Bash shell scripts, the C programming language. I mentioned this is a full general purpose programming language. There are some faculty who think of it kind of as a little language because it actually is a very simple language. But because of that, it doesn't really protect you from some of the things that you've come to expect protection from. And so it's easy to accidentally stub your toe while you're programming in C. Regular expressions, as I mentioned before, are for searching and replacing in text. Makefiles, we'll learn, are a technology or a little language for describing how a project gets built. And so if you have a project that's complex, like a web application or a mobile application or a GUI-based application that has many different parts of its build, you'll see that makefiles are very valuable, and we'll learn about that. We'll take some time to learn Markdown. This is a very commonly used today markup language for writing technical documents. And there will be some others, but these will be the ones that we spend most of our time with. This course is absolutely not going to teach you all of the tools. We'll learn that there's way more tools than any human could ever know at this point, because most programmers tend to invent some of their own. But what we will see is that there's some commonalities, and there are certain classes of tools that once you know how a tool in this family of tools works, you'll be able to apply what you know about it and learn something else that might be specific to some other programming language. Right? So just like there's no human that knows every spoken programming language, there's no human that knows every tool or little language that is around. But we will learn how to think about these things and some of their structure, so that if you wanted to go implement them on your own, or you want to learn much more commonly, you want to learn some language that someone else has written to solve some specific problem, it becomes much easier when you can think about their structure and some of their first principles. All right. One of the things that I think is a little bit strange for students in this course is realizing that many of the tools that we're working with were invented in the 70s, right? So that's over 50 years ago now. And rather than thinking of these things as old, what I want to encourage you to do is think of them as things that were so valuable that we haven't been able to replace with something better. and this is proven by, like, go out to Google or Facebook or up in Sitterson Hall as people start working there again, and you'll see that people haven't found, like, these are the tools that real software engineers are choosing to use today because they are so valuable and were so well designed initially. So let me jump and just see. All right, so I've got some questions here. Let me move through a couple of questions real quickly. How is C different from machine language? Well, so this is a question that gets to the idea of representation. And what you'll see is C is going to feel pretty familiar. It looks a lot like Java because Java descended from C. Java is in the C family of languages. So you'll see there are curly braces around your blocks of statements. There are semicolons at the ends of your statements. The for loop syntax is the same. There's a lot, the way that you declare the type of a variable and specify a function signature is very similar. So there's a lot of syntactical similarities with Java because Java was a descendant in the C programming language family. So to compare that with machine language, just very briefly, because it was a great question, machine language is much, much simpler than that. Machine language is like, hey, add these two numbers in the specific place in memory, or go copy one cell of memory somewhere else. It's very, very simplistic. And we'll see a little bit more about how simplistic it is. In the next course, you'll get the opportunity to write machine language, and you'll see that it's much more tedious than you would expect. There's a question of, will I post the slides before lectures? Yes, I will in the future. And there's a question of IDEs for this course. We'll be talking about that. And we're actually all going to be using the same software development environment. And I'll get into a little bit more about the tools that we'll be using in this course. And will these be recorded? Yes, these will be recorded. In the future, we will have more live interaction where we do polls and have Zoom groups that are going on simultaneously. But these will be recorded so you can access after the fact. All right. There's a question on a grading scale as well, and I've got a slide on that, so we'll get there in just a moment. So there are a number of upper division courses that in recent years we've found students didn't seem to be adequately prepared for, and we thought that this course would be an opportunity to better prepare people for these courses. So if you've heard that some of these courses are really difficult, what I want you to know is after completing COMP211, you'll be much better prepared to succeed in these courses. And there's a strong relationship between them. So if you want to know how computers talk to one another and how the internet works and how games where you have multiplayers works, COMP211 networking is all about this. It's all about how does email work and how do you write protocols and think about protocols. And you learn about the layers of the networking stack. As I mentioned before, COMP455 is David Plaisted's famous course. And this course, you learn about languages and how to prove certain properties and computation. Compilers was my favorite course as an undergraduate at UNC. And there you'll learn about how a programming language that we write gets translated into something that's closer to the machine. And we'll spend a little bit of time introducing some fundamental concepts from compilers, and you'll get more exposure to that in COMP520. And lastly, operating systems is the course where you learn about how something like Windows or Mac OS is structured and how an operating system is able to switch between different processes and applications you're running without getting bogged down. All right, so I mentioned before, and I'll just put this slide up one more time, how to ask questions is here. One question is this course asynchronous? It's going to be a mix. We're going to have some synchronous points where we will be on Zoom and getting into small groups. We're going to start that either Wednesday or Friday. I'll talk more about that once we decide on that. And there will be some asynchronous components that will be pre-recorded lectures that you'll do on your own. And is this the closest to the machine you can get from a software perspective? That's an interesting question. Pretty close. In 311, you'll write assembly code, and assembly code still isn't machine code. It still needs one more step because you're writing it in something that you can understand, and the machine really only understands binary bit patterns of zeros and ones. And so assembly you would think of as a little bit closer to the machine. All right. Last question before I move on, is 455 similar to 283 and 381? Yes, 283 and 381 give you the fundamental tools for being able to succeed in 455. And in a way, you're learning the math in discrete math for being able to prove and think about the concepts that you need in order to understand the theory of computation, because the theory of computation is all based on sets and Boolean logic and things like that. All right. So let's talk about the tools that we'll need for success and some required computing capabilities. You must have something that meets the Carolina Computing Initiative standards. All right. So if you bought a CCI laptop, you're golden. If you didn't buy a CCI laptop, I'm pretty confident we didn't have anybody that ran into this in the pilot, but there's a chance that if you cut it really close on the RAM or something like that, that we may need to look for alternative solutions. But this is a course where we're going to be working with like cutting edge industry software in Docker and virtual machines, and having a computer that's capable of doing that, which all CCI laptops are, is required. If you're on Windows, you're going to see that there are some instructions for getting started. And this is the most important thing for you to hear today, because it's going to impact how you get set up for success in this course. In May, Microsoft released a really important update to Windows 10 for the purposes of the type of work that we're going to be doing. And pretty much everybody in industry was pumped about this who develops on Windows, because it made a certain component of Windows much better. And that's WSL2, which is Windows subsystem for Linux. It's highly likely you're going to need to update Windows to this. And in the getting started instructions, we've got the step-by-step on how to do it. And the main homework for tonight is going to be updating your operating system and trying to get the software installed. And I'll talk a little bit more about that shortly. All right. If you don't have the latest update of Windows, if you have a pretty old version of Windows, it might take an hour or two. If you've got a more recent version, it shouldn't take more than 20 minutes. All right. And if you're on a Mac, you're probably okay, but we're going to encourage you to update to the latest version of Mac OS so that you've got all the security updates and the tools that you need. If you're working on Linux, you should be fine, but you're going to be a little bit more on your own, but that's to be expected if you're already working in Linux. There is a required textbook for this course. It is the C programming language written by Kernahan and Ritchie. These were two of the original developers of the language, and this is the de facto book on the programming language. You'll see that it was written in the late 80s, and one of the things that's fascinating about this book is how well it stood the test of time. One of the other professors in the department said it well, that like no other book has done a better job of teaching C than this one. And this is a book that if you have it on your bookshelf and other software engineers walk by you, they're going to be impressed that you have it. So getting this book by next week is required. People have found things online, and as long as it matches up, that's fine. But this is one that I think is good to have on any computer scientist bookshelf. There's another text that is Learn a Command Line Interface, and this was written by me. It's free. The PDF is in the resources area of Sakai. And there's only 2 chapters in here, as well as the getting started information that are going to orient you with working in a Unix command line environment. All right. So I'll have the schedule of when things are due in just a moment, and on the final slide, and I'll send out an email about this. But effectively for next Wednesday's class, it's really just getting software installed, and the instructions for doing that are in this resource under Sakai's resources page. All right. So someone asked about the graded components of the course. There's going to be a 50-50 split between the things you do for preparation and practice that include programming labs, where we're writing C programs, we're writing make files, quizzes, and guided readings. So when we have readings, there will be grade scope assessments that are multiple choice that ask you to confirm or probe your understanding and confirm your understanding of certain passages in the text that are very important. And then we'll have in-class participation, and there will be synchronous components of this course. You should not assume that this can be completed asynchronously. We will have regular synchronous activities. Right? The other 50% of the course is mastery, and there will be 2 midterms and a final. The dates for these, including the final, kind of bizarrely, the registrar for the first time since I've been here hasn't had a schedule of when finals are. But as soon as that final is scheduled and a few more details sort of are resolved on our end, we'll get the complete schedule of midterms and final released to you. Right? So if you need to be absent for one of the midterms, the final will take its place and be worth 35% instead of 20%. And if you take both midterms, which I would encourage everybody to do, then the final exam, if it exceeds the score of either of your midterms, will replace up to one of them. All right. So we had a similar policy in 110, but there are fewer assessments in this course because we're going to spend more time on programming. Again, to pass this course, you have to have a passing grade across the graded components and score higher than 40% on the final exam. Right. For the guided reading questions, there isn't going to be much flexibility on late points. We want people to stay on top of being ready for the course, and we'll give plenty of time to complete the readings. This is really important for just not falling behind. We do move quickly in this course. There is a lot of content that needs to be covered, but as long as you're staying on top of the readings and actively engaging with lecture, you should be just fine. And we will drop 2 of the lowest GRQs, including 0. So if you miss one, it's really not the end of the world, but just don't get too off track, right? If you need to turn in a late programming assignment, that's fine. We will accept programming assignments late for up to 2 days, and there will be a late penalty applied. There will be a forgiveness period in the 2 hours following a deadline where we won't apply the late penalty. But after that, the 20% will apply. Right? So we're going to be using course care that many of you used with me in 110 to do office hours, and we'll start having office hours tomorrow and through the rest of the week for helping people get started. The code to get set up, which I will post on the website and email to everybody, is shown here. So don't worry about getting this down yet. I'll email this around. And I'll give a demo for those of you who didn't take 110 with me, how course care works. And I'll probably do that asynchronously, so we don't use synchronous lecture time for that. We're going to have Piazza going for the start of the semester at least in order to help navigate common issues that people might run into when getting set up. So do look there first. If you run into an issue during the setup, check Piazza, and if you don't see anyone to solve your problems and office hours aren't currently open, do make a post on Piazza, and that's going to be the best way to get help quickly. And then just like in 110, we're going to be assigning each of you UTAs and forming smaller groups within our class of 117 last I checked. All right. So I'll talk about emailing and things like that as soon as we have those assignments made. For now, the best thing you can do is just post to Piazza. Right. Looks like there's 3 questions. Let me check. For missing lecture purposes, I will drop. Basically, the policy that I use in my courses is as long as you're showing up to 80% of lectures, you'll get full participation credit, right? So if you miss, every 5th lecture or something, it's fine. And generally, everybody gets close to full credit. But if you're consistently missing, that's a little bit harder to reconcile with. All right. Someone said, holy cow, my dad used that book, and it was the C programming language. And that's absolutely right. Like I said, that book's about as old as I am, but C itself hasn't changed. And having a sense of being able to navigate a book like this was very intentionally chosen over many of the books that have come since, because it's such an important book in the history of computing. And when it comes to the C programming language, it's the de facto standard. It's a really well-written book, and I think is the right book for where you're at in your computer science journey. All right, so right now, many of you might be feeling a little bit like this young woman from Jurassic Park, right? And I've used these slides once before, and I tried to embody with some memes where we're going with this course and my hopes for it. All right. In the next 4 to 5 or 6 weeks, you're going to feel a little bit like you're crawling around on all fours because some of the things that you're used to being able to do very easily in something like Eclipse are going to be a little bit harder to do in a tooling environment like Vim and the command line. And so you're going to find that you feel like you're being chased around by a dinosaur and some old technology, when really you're learning some fundamental skills, because by November, you'll feel like this young woman who has one of my favorite movie quotes of all time. It's a Unix system, I know this, where she's presented with a computer, she navigates a directory structure and ultimately locks the doors to save her and her brother from a dinosaur. And we're going to be learning the Unix system and Unix family of systems such that you'll be able to save yourself in a very similar situation if you need be, or much more likely if you go out into industry or a lab around campus, you will very confidently be able to navigate a command line, which is what most people use when putting together data processing pipelines and many other tasks. I like charts, and so the other chart that's a favorite of mine is this one, because I want to set some expectations. Many of you had me in 110, and this course is a little bit different from 110, and we are digging in deeper than we did there. So just to set some expectations, if we take a chart where on the x-axis we think about time, and the y-axis is your love, enjoyment, and appreciation for the work that you're going to do in COMP211. What I can promise you is that right now, if we think of ourselves at the origin, at some point, we will be in the positive on the love side, right? We will get there. And you, the TAs, and I are going to have a fun time getting there, but you're probably not going to start on the positive side of this. There will be a stretch of time where we start out in the negative, right? We have to sort of take a few steps back in order to make our way to the promised land of being more confident and comfortable with systems programming, right? Now, I didn't label this x-axis, so what I can't guarantee you is whether or not like December is here, which is the hope. And I think after having taught this course a couple of times now, this feels almost reasonable. But some of you, December might be here. And I have heard from some former students who took this course who, came out hit or miss on the other end of it. But I heard from them after an internship, and the common anecdote that I've gotten is, wow, I'm so glad that I learned these tools and took this course. It was so helpful to me in actually getting up to speed and knowing what was going on at my internship. Throughout this semester, I would love for feedback from you, and there will be a number of channels for this. I'll ask some surveys as we get through the course in this semester. All aspects of the course, this is only the second time that this course specifically is being taught, so there's room for iteration and improvement. So feel free to email me or talk with a UTA, and they tend to share feedback back up the chain to me as well. But please give us feedback while we have time to act on it. I think it's always a little bit disheartening to hear feedback at the very end of a semester on like a course eval after the semester is finished, when that feedback could have impacted the way that we ran the course. Especially this semester, because all of this is so new. We've never taught remotely before. We're trying out some new things with YouTube. We're going to be using Zoom and trying to make the best of all of these mediums. So just please, if you have feedback or ideas, I'm happy to hear them, and we will act on it. And as I mentioned, I'll take some class-wide feedback as we move through the semester. All right, so it looks like 2 more questions have come in. what are some things that we can look forward to making with this class? So I love that question. My favorite thing is sort of the project we end up with, and where we went last semester, and I think we're heading in a very similar direction this semester, is actually implementing a command line shell and understanding how a shell is able to take a command and then go ask the operating system to run a process and manage and know when that process completes, and do some other things. And so like when you type into a shell program, it feels like this is something that's built into your computer. Like, how does this work? This for my own part, like I have to be very honest with you all. I was over 30 years old before I built my very first shell, or tried to, and it all felt like magic to me up until then. So I'm very happy to say that that you will not be 30 years old when you write your first shell. And this gives us some really good practice with some fundamental concepts like tokenization and working with textual inputs, as well as system calls and writing a non-trivially sized C program that's well designed. So the format of the midterms and the final are a little bit TBD. I don't want to commit to anything quite yet, but it's likely they'll be on Gradescope. I think we're just gonna have to see how things feel when we get there. That's one thing that I think it's just going to depend on how things go this semester, and there'll be plenty of time, and I'll give you advance notice on what to expect when we get there. So don't stress on that too yet. What is a shell? All right, let's see. I've got time to open up a shell really quickly. All right, so if I pull up this window, and something that you will be installing, let me just see if I'm up and running. Okay, so what I'm doing right now is starting up a container, and this is actually what you will be focused on. In your getting started instructions are getting to the point of being able to run this, what you're seeing here. Right, so a shell is this command line well, actually, there's two ways to think about a shell. Where'd my pen go? It's in my pocket. All right. So if we think about the operating system, and you'll see me draw something like this very similarly in the future. If we think about the operating system, that is Windows or Mac OS, and the operating system has a kernel, which is sort of responsible for fairly sharing your computer's hardware resources, right? Like your hard drive, the network, your screen. The operating system is trying to arbitrate access to these resources. And we call this the kernel because it's sort of central to the operation of your computer. And it's going to control who has access to what. And so outside of the shell, or sorry, outside of the kernel, we have the shell. And you as a human, when you interact with the shell is translating your request into actually making the operating system commands to or API calls in order to carry those things out. So there are two kinds of shells. There are graphical user interface shells. That's what you're interacting with when you're clicking on Windows in interacting through a GUI, graphical user interface, or working on a phone. And then there's a text-driven shell, which is what we're actually seeing here. And the first set of readings that are from the how to work in a command line environment text are all about the shell, and will get you more comfortable with this terminology. But what we can do is we can run programs, right? So one of the first programs you'll see that's important is learning how to list the files that are in a directory. And so the ls command is doing that. And so what you're going to write is actually the program that you're typing text commands into, such as echo hello world. And your shell is going to take this command here, like echo hello world, and break that into what are the important parts of that command, and then how do I start the program named echo, and some other things. All right. So what a shell is will make more sense as we get into learning about it. And that's one of the fundamental, like in the beginning of the course, we'll be learning how do we navigate within a command line interface shell. And at the end of the course, we'll look at, well, how do we actually make a command line interface shell generally. All right, there's one more question. All right. For attendance purposes, once we get going on Poll Everywhere, questions that are not just Q&A like this, but are actually responding to questions, we'll use responses. Most of those responses will be participation based only, but are meant to be very good practice for being comfortable and competent in the material that you're learning. All right. So the things that you need to be working on for Wednesday, you really want to be working on getting your software set up. And this is a non-trivial task. We're installing industry-grade software. You're going to have to be upgrading your operating system to the latest version. We're here to help you with this, but and actually this isn't the OO installation PDF. Let me fix that real quick. This is going to be learn a CLI.pdf book, and it's the sort of prereqs chapter, right? So I'll link out to this as well, but it's effectively the prerequisite for being able to get started in the book is being able to run that command line interface in a Docker container, just like we showed you. So you'll get to that point of seeing the UNCCS on your screen, and then we'll get more comfortable working in this environment over the course of the next few weeks. By Friday, the first chapter in that book is the introduction to the shell. So that's where more of this terminology will be revealed, and you'll get more comfort and practice in a very tutorial-driven way, learning what a shell is. And then on Friday, we'll have our first grade scope-based quiz. And for quizzes, we'll allow handwritten notes, so you can take notes, but you can't refer back to the book, and it's going to have to be honor system for doing this. But I trust you all, you're Carolina students. And the point here is just to get comfortable with the tools and start getting comfortable navigating around the shell. And that'll be on Friday. And then over the weekend, the second chapter is going to be getting used to working with directories and files and paths, also in the command line environment in the shell. And by then, hopefully by Monday, you'll be able to get a handle on the C programming language book, because we'll start having readings from that next week. All right. So there are a few more questions here. First, where do I recommend getting the book from? Amazon's totally fine. I don't think I can publicly recommend any shadier way of obtaining the book. I do think this is a book that people found, and I believe there may even be a version online that's acknowledged by the authors. So if you search around, this is one though that I think is good to be able to scribble in the margins of. And I don't think this is one that you would feel bad about having on a bookshelf. This is a 3-hour course, and is C used mostly for writing operating system programs? Yeah, so most of operating systems, the Linux operating system and fundamental parts of Windows and Mac, which is based on something called BSD, are written in C. So C is sort of the de facto low-level systems programming language. We may spend some time at the end of the semester looking at a newer programming language for systems programming that's starting to take hold called Rust. But C really is, if you wanted to make something in the Unix programming or operating system, like something at the operating system level, it really is the de facto standard language currently, and still for the past 30 years. And I think there's one more question, and then we'll wrap up just a bit early here. So is a shell simply a middleman between hardware and the user? Yes, that's absolutely how you should think about it. A shell is really trying to give you, the end user, a simpler way for interacting with your computing system than having to write a program each time you want to do something, some new task, right? So the shell is going to be, once you get comfortable working in it, you can do things that like would be hard to even imagine currently. And you can work much more quickly by tying many different programs together, by working with files in a way and streaming the contents of files into your programs in ways that allow you to write smaller programs or separate out the programs of some data processing pipeline rather than having some giant solution in a big project. So it's really you think of it as the programmers or the systems engineers workbench for doing their job. All right. I'll talk about quizzes in a little bit more depth on Wednesday, but I want to wrap up here and direct you towards the Sakai site, where you can find the syllabus for the course, as well as the book to get working through, including the instructions for getting started. We've got the Piazza open, and you should have all been invited to Piazza. I'll re-import the roster one more time in case there are any late adds. But if you have trouble getting started, Piazza will be the place to ask questions. And as soon as we have a schedule of when to work with TAs and office hours, I will send that out through email as well. This is a course that I'm really excited to work with you all with virtually. As I mentioned, we'll be doing Zooms here soon. We needed the TAs to get a little bit more organized because really the emphasis that we have on Zoom is going to be when we Zoom, we're going to have group interactions with one another. It's not just going to be a lecture style like this one where it's all me talking to you. We will have asynchronous components where I'll pre-record videos and you can watch them more at your own time, so you don't have to be here at this specific hour when you're doing it. And we're going to try and make the most of both of these modalities, right? We'll use synchronous when we want to like review something specifically and be sure everyone's on the same page and making progress. And we use asynchronous lectures to deliver material that gives you a chance to go back, rewatch, and relearn. All right. That is all we've got for today. Again, if you have further questions, ask them on Piazza. I'm really excited for this semester, despite how weird and crazy it is to be teaching in this format. But I appreciate your attention today and all the great questions on Poll Everywhere. And we will see you back here on Wednesday.